In this tutorial, I want to solve two more gas-related problems. The first question is, what is volume of 0.1 mole of carbon tetrafluoride at 25 degrees Celsius? Now realize this is not STP, this is rather room temperature and pressure. So you cannot use your shortcut of 1 mole being equal to 22.4 decimeter cube. Therefore, I have no choice but go to ideal gas equation. Then again, this is a gas that its boiling point is way above room temperature. Therefore, this equation is appropriate. Since they are challenging me on volume, I divide both sides of equality by pressure. On the left-hand side, I only have volume, which is equal to number of moles times gas constant times temperature in Kelvin divided by pressure. So let's just plug in and solve for it. So number of moles is 0.100 moles. The identity of the gas is not important. Times gas constant 8.314. Hopefully you remember it's kilopascal times decimeter cube divided by mole times Kelvin. Times temperature converted to Kelvin, you always have to do that, add 273, so it's 298 Kelvin. Divide the entire numerator by the pressure. Although you have to convert your pressure to kilopascal, take it 3 decimal places to the left. So it's 1.2 times 10 to power 2 kilopascal. Like units cancel each other out, moles go away, Kelvin goes away, you're left with decimeter cube. Your final answer will be 2.06 decimeter cube. So the problem is solved. Although I want to solve it again, this time I don't want to change my pressure from Pascal to kilopascal, and I want you to note if you don't do that, then your final volume will be in another unit known as meters cube. So let's see what's your final answer. nRT over P. Plug in everything except don't change the units of pressure. So you have 0.100 mole, just as before, times gas constant did not change, 8.314, except instead of kilopascal I have pascal, instead of decimeter cube I have meter cube. That's all it changes. Mole times Kelvin, temperature as it was 298 Kelvin, divided by pressure is 1.2 times 10 to power 5 Pascal. If you do this, your final answer will be 0.00206 meters cube, or 2.06 times 10 to minus 3 meters cube. This is your final answer in new unit. So one thing I want to emphasize now is that 1 meter cube is equal to 1,000 decimeter cube. And you remember that 1 decimeter cube is simply equal to 1,000 centimeter cube. And finally, don't forget that 1 decimeter cube is nothing but 1 liter. So these are some quantities that are related to each other, and you see what happens when pressure is Pascal, your unit will be meter cube. If you convert it to kilopascal, which I prefer, your unit will be decimeter cube. Now let's look at the second question. This time there is a gas problem, but they're challenging us on molar mass. So they give us a mass of the gas, m, small letter m, representing that. They give us the volume. Immediately I convert it to decimeter cube, so 0.282 decimeter cube. They give us the unit in Pascal, so I'm going to take it 3 decimal places back. So the pressure for me is 1.02 times 10 to power 2 Pascal. And also they give me temperature that definitely is not STP. So the Kelvin is simply 273 plus a minus 18, which is take away 18, and it's 255 Kelvin. Now what is molar mass? All I know is PV equals nRT. Where is molar mass? But you also remember that moles is nothing but mass divided by molar mass. So let's recombine and insert, instead of n, we put m over m subscript r. And I'm going to get rid of m subscript r, so I don't have relative. I have molar mass in actuality. So PV equals m over capital M for molar mass times RT. Now I want to solve for m, so I want to make it as easy equation as possible. I multiplied both sides of equality by m, so m times PV, and multiplied by m. On this right hand side, m's go away, so molar mass times pressure times volume is mass times R times T. Divide both sides by pressure and volume, then you only have molar mass on the left hand side. So finally the new equation is molar mass is nothing but mass times R, gas constant, temperature in Kelvin, pressure, volume. What I need to do is just plug it in and be careful with the units, and I have solved the problem. So mass was 0.586 grams multiplied by gas constant 8.314. For us IB students, don't change. It's kilopascal times decimeter cube divided by mole times Kelvin, multiplied by your temperature in Kelvin, which we calculated to be 255 Kelvin, divided by pressure in kilopascal, so it's 1.02 times 10 to power 2, sorry, this was kilopascal, times volume in decimeter cube, which is 0.282 decimeter cube. Now like units then again go away, kilopascal, decimeter cubes goes away, Kelvin and Kelvin. What you're left is grams divided by mole, so your final answer, double check, double calculate, is 43.04, 4 significant figures, grams per mole. This is molar mass, so 43.04 grams times mole to -1.